Greetings to all of you. In this lesson module, we are going to learn about recursion. Recursion, it is a concept which is used in functions where a function can be calling itself, which is called as recursion. So there are two kinds of recursion, the direct recursion and indirect recursion. Our focus is going to be on direct recursion in this lesson. You would have done the problem for finding the factorial of a number, and when you're doing this factorial, now this is in C++, this is a program for finding the factorial of a number, where we normally do it with loops. When you do it with a loop, the main loop is focused here, and if you see that I varies from 1 to the number for which you want to find the uh, so this is the loop which mainly finds the factorial of the number, and if no represents the variable which for which you want to find the factorial, and for example if 5 is going to be the number for which you want to find the factorial, then the loop will be repeated for 5 times. Initial value of I will be 1, and the factorial value is initialized as 1. So fact into I, so 1 into 1, first iteration of the loop will be 1 into 1, answer will be 1 which is stored in fact. So next iteration will be 1 into 2, so that is equal to 2. So 2 into 3 for the third time, which will be 6, fourth time 6 into 4, so 24, and final round will be 24 into 5, which will become 120. So 120 is the result, and that will be printed out in the cout statement. So this is a process which is done using the for loop. Same you could have written using a while loop or do while loop, or even a simple conditional check, which is checking for the number of times you want to perform a set of statements. So this is a normal program without recursion. The same if we want to do it with recursion, then we need to write a function where the function will have the parameter being passed. So fact is the name of the function that we have written here for finding the factorial. And when we are using recursion, we should not use loop. This is one main point which you should always have in mind. When we are making use of recursive concept, then the looping is not needed, because internally the recursion will naturally make use of a looping construct which is inbuilt. So the compiler will take care of that. And also while learning data structures, you should be aware that these recursive concepts are implemented only using a stack. So internally inbuilt stack will be there, and repeated calling of the function will automatically happen till a particular condition is satisfied. So now in this example, you will understand the whole concept. So fact is the name of the function that we have for finding the factorial, for which the parameter, there is a single parameter n. So it is being passed on to the function, recursive function. Now in this recursive function, if you see, it is a condition. The formal parameter a receives the actual parameter value from n, and it will make use of it in the function. So now it checks whether a is equal to 1. If a is equal to 1, then it will return the value result as 1, and the process will end there. In case a is not 1, then it will come to the else part, and this is what is the recursive part here, where we want to call the function again with a minus 1. So a into fact of a minus 1. So for example, if it is going to be 5, then 5 into fact of 4. Then with the value of 4, it will again come over here and call again. So now a minus 1, the value for a will be So this is the example that we had been seeing, and if factorial is to be found for factorial 5, the value of n will be 5, and this is the recursive algorithm that we have written. And every time you call the same factorial, it is calling itself. That is what recursion is all about, and direct recursion. And every time it calls with one value subtracted from the actual value. So a into fact of, if original a is 5, 5 is not equal to 1, so false. It will come to else, written 5 into fact of 5 minus 1, which will be 4. So again the function fact will be called with the value of 4, a being 4. So 4 is not equal to 1, so again false. So it will come to return 4 into fact of 4 minus 1, which will be 3. So int a will be again 3. Fact of 3, 3 is not equal to 1, so false. So 3 into fact of 3 minus 1, 2. Fact of 2, 2 is not equal to 1, so false. 2 into fact of 2 minus 1, 1. So now it will call with fact of 1. When it is calling with fact of 1, a will become 1, 1 is equal to 1, so the final value will be returned as 1, which means it will function like this. Now it has come till this, fact of 1 minus 1, it cannot do, but before that 2 minus 1 itself will return the value of 1. So 2 minus 1, fact of 1 value will be written as 1. That value will get substituted here. So 2 into 1 is 2. So that value is the result for fact of 3 minus 1, which is 2. So 2, 3 into 2, 6. 6 is the result for factorial of 3. So 6 into 4, 24. So that is the result of this call. So every call value is remembered in the stack, and that returns the value to each of the previous call. So final value will be 24 into 5, which is 120, which is the final value. That value will get returned here. So we don't need a separate loop here to solve the problem, but recursion itself internally manages the repeated call, and by using a stack, internal stack is there, the compiler provides an internal stack. So recursion will be possible in any language which supports a internal stack. So the compiler should have been designed in such a way that it supports an internal stack. If that is there, then any language can support recursion. Now this problem is solved here using C++. This is to find factorial. Any suitable problem that needs to be solved using recursion can be solved with recursion, like even Fibonacci. Normally all mathematical problems which has a similar repeated process, that can be solved using recursion. So that is about recursion, and this is about direct recursion. Thank you.